Yeah! Something going on. Yeah! Yeah! Something going on in the neighborhood. Why do we see much further than we should? You're sick of the lies, sick of the lies. Who you gonna call when you get on the line? Who you gonna call? Who you gonna call? Who you gonna call? Yeah! GLOBEBUSTERS! 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 If there ain't no curve, there ain't no ball. The globe religion about to fall. We're gonna open your eyes so you can see who you gonna call if you wanna be free. GLOBEBUSTERS! 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 Who you gonna call? Who you gonna call? Who you gonna call? Yeah! GLOBEBUSTERS! GLOBEBUSTERS! GLOBEBUSTERS!
And welcome everybody to GLOBEBUSTERS. We accept the reality of the world with which we're presented. It's as simple as that.
Hello, everybody, and welcome to GLOBEBUSTERS Tech. I am your host, Zach, Good Times for All, and today we will be talking about auroras. Now, this is a topic I haven't done a whole lot of research into. I know pretty much the basics that a lot of the flat earthers went through back in the day, but this is something I've never really delved into too much. But we do have some articles and some videos and stuff to share with you about people trying to recreate it, of what it possibly might be. In my opinion, it's definitely electrical. I mean, when we ionize gases, they light up. I can do it with my Tesla coil right back there in the corner, and the gases that I have in test tubes have shown this at Flattoberfest last year. And yeah, I had so many of the it was really interesting. Flattoberfest last year, there was a lot more college educated people just getting out of college. And that was the one thing that they were so fascinated with more than anything, more than the gyroscope or this or that, was when they saw that Tesla coil fire up and all those gases just light up. They were just like, wow, that's amazing. We never got to see anything like this. And they were college educated. That's sad that they never got to play with that kind of stuff. But before we get into talking about auroras, we're going to introduce the panel. First off, we have Miss Karen B. Karen, how are you doing today, ma'am?
I'm doing fantastic. Good to be here.
It's always a pleasure to hear your voice. How is the festival coming along? Everything going smoothly, I hope?
I mean, as smooth as it can be.
No different than any of the others?
Yeah, well, no, it is different because it's a remote location and it's very different, and it's been a lot more work and a little bit tougher than the other ones, but I'm sure it will all be worth it.
Is it kind of tough with so much distance between you and it right now?
Yeah, it's a little difficult. It's difficult too because it's in a hotel and there's like not already a stage there and that sort of thing. So
You'd think they'd have something like that over there, especially with
yeah, but those big ballrooms, they
Vegas.
don't. It's a
Yeah.
blank slate.
Wow.
So I
Yeah,
got to
that's how
build the
they-
stage and the lights and the screen, so it's different, but
A
it'll
lot
be
of work
great.
goes into it, but you do amazing every time.
Well, thank you.
And the technical stuff, I heard Nathan talking to the sound and audio guy, and they're sitting here saying all these words. It's like he's speaking a different language. I had no
Uh-huh.
idea what he just said,
Yeah.
but the guy knew exactly what he was talking about and everything. I was like, wow, that's
Mm-hmm.
wild. All right. And next up, we have Mrs. Cammie Nodell. Cammie, how are you doing today, ma'am?
I am doing good. I'm having a little bit of problems with my computer, as you know. We had a wind gust come and take it all out because I have an office in the sunroom, and that is the danger. Is if you get a rogue 60-mile-per-hour wind gust, monitors go flying, and they did. I've got it back together. I'm still working with the connections, and my camera was going on and off, so I'll probably have it off. It's not a great loss for y'all tonight. This has been a heavy work week here. We had carpet replaced and other things like that. So we're just a sweaty mess. I think it's probably better not seeing me, but it's good to be here tonight.
Well, it's always a pleasure having you. And last but certainly not least, Mr. Kyle Adams. Kyle, how are you today, sir?
I'm doing fantastic. Happy to be here as always. I think this topic really excites me because there's a lot more mystery involved in it than a lot of people really take it credit for. And the Globe Earth thinks it's all figured out, but yeah, I've got so many questions about it. And like, I'm just kind of laying awake at night, just thinking about, wonder how this works. I wonder how that works. And yeah,
So have
just,
you ever seen it? The Aurora Borealis?
I've never seen it in person. I've just seen videos of it, and I've been trying to get in contact with my Canadian friend Sasha over there. It was Orphan Red. She's Canadian, and trying to find out what she's seen of it. And haven't heard a response back from her yet on that, but we'll see. So yeah,
I've seen it one time. I was driving. It was winter time. I was in northern Indiana, about 41 degrees north latitude, and me and my cousin were just going for a cruise out in the country. We were just bored, and it's really beautiful when it's really white out, and there's like a bright moon. You can turn your headlights off because it's just snow fields and a black road, so you can see where you're going even in the dark, and you can tell if anybody there. Nobody would be coming. I mean, we were out in the middle of nowhere, least populated county in Indiana. I loved it. So we're driving along, and the only lights that were on were the lights on my the dashboard lights. And I look at my window, and it's all green up here, and my dashboard lights are green. And I was like, well, that's weird. I've never seen my dashboard lights shine like that before off my the window. So I rolled my window down, and the lights were still there. And I was like, no way. So we pulled the truck over, and me and my cousin just sat there for like 5-10 minutes, just sitting there looking at them, because we had never seen anything like that before. Yeah, just green. It was just like a green hue. It wasn't moving or anything, but it was just sitting there like this green hue in the sky. Now, normally it doesn't come that low. That was, I mean, living in Indiana for 40 years, I saw it one time, and I was probably about 31, 32, somewhere right around there. But yeah, that
I
was
think
the
it's kind
only
of
time I ever
one of the really crazy mysteries of it is how it's so locational. It's not everywhere. Why can't we see it everywhere? Because the entire sky is electric, right? And so I understand we see a lot of the ionized gases in the atmosphere during the sunsets, like the pinks and other colors in the sunsets, and that's my big understanding of it. Is we get a lot of those different colors from different the electrified gases in the atmosphere from their distance from the sun. And so that's a big part of my understanding, but I'm kind of wondering about the overlap between that and Aurora.
Yeah.
And
Yeah,
how
well,
that's different. Yeah.
it's almost as if, thank you again, T. Baggins there, $5 super chat, going to his first Flattoberfest, or their first Flattoberfest this year. Looking forward to it and feeling the high vibrations. Thank you, Karen B. Thank you. Yeah, I can't wait. Yeah, it's interesting because the lights we see in the auroras are, I mean, we don't see many green sunsets, or these, I mean, some of the aurora colors are the same when you go and look at the videos and everything, but that weird green that it gets, we don't see that happen in the sky very often, that color. And to me, it's almost like there's a different gas that's being lit up almost. And it happens when it's the coldest in these areas. It never happens like in the summertime in the northern hemisphere. It's usually when it's colder in that region. And I almost want to think that the gases kind of come down a little bit,
Mhm.
maybe. Or I have no clue really.
Yeah, like you said, there's a lot of mystery there that, yeah, it's really kind of fun and exciting to look into.
Yeah, they have lots of different measurements and stuff like that of like what happens to the ionosphere in the winters, and they always say in the winter it seems to come down a little bit because there's not as much pressure there and not as much potential energy underneath it to hold it up
Yeah,
because
well,
most
I
of the heat
understand.
is.
Yeah, in the wintertime, that's when the atmosphere is a lot drier. And so you're going to have a lot less density down low.
That's a great point. Yeah, because water, especially pure water, water that's been distilled or in the process of being distilled, is the greatest insulator that we know of.
Yeah.
It's better
Yeah.
than rubber, glass, anything. You can name any of them. And water's like 100 on the scale, where the next one's like 10, maybe. It just, but we can't apply it to anything
Yeah.
technologically. It'd
That's
be
why
too.
whenever we go out and do those laser experiments over frozen lakes, we do that at that time for a specific reason. And that is so we can get a farther range of vision. All of that humidity in the atmosphere in the summertime, it's going to limit our range of vision. But when it's really dry and really cold out, that's when we have an extended range of view. And that's really what proves the flat Earth right there. That was kind of one of my first big flat Earth proofs that really kind of opened my eyes to all this.
Well, here's a video. I think you dropped this in there, Kyle.
Mhm.
And this is what NASA says. And now this should be fair use. It's a .gov. So aren't we allowed to disseminate this?
Yeah, if it's
All we
NASA,
want
yeah,
NASA, we're allowed
yeah,
to share everything. Yeah, okay.
yeah,
That's
we're
what I
good.
thought.
Especially if it's educational purposes, which we're trying to do and do commentary on it. That's totally cool.
Wow. Space Miner has seen a red aurora in northern New Mexico. I know there's a lot of mountain ranges up there in northern New
New
Mexico.
Mexico,
That's
seeing Aurora.
way down there. Yeah.
Yeah,
That's awesome.
how
Yeah.
did
I used
that happen?
to middle of nowhere. I was very, very into space weather, and so one of the alerts I got was when the KP index hit 5, and and then 6 and 7s were like in Colorado where we would get the auroras. So I would get notices when the auroras were visible in Colorado, but I was in the Denver metro area on the edge of it. And I went out countless times over like the years in the middle of the night and the different things, and tried to see them. And maybe I saw like a little bit of flickering or things like that, but nothing eye-catching like you see in the movies. Bob had seen the auroras when he was in Alaska and talked about them a lot, and was entirely fascinated on them.
That's what
Some
I
of
would love to go up there to Alaska and see the
Just
auroras actually extend past my head, like, and just the whole
right.
sky be like that. I saw it and it was like off in the distance, just above the horizon. It wasn't, right there. That'd be so cool.
yeah, just seeing them itself, that's like worth the trip right there.
Yeah, absolutely.
Now, some of the discussion between the difference between the sunset colors you see and the gases igniting and the auroras is going to be obvious. That we know that probably the sunset ones are affected by the sun, and the sun doing it and hitting the things on it. Your auroras are different because you're seeing them at night and you're out of the sun's cast on it. So that could be too, is that you're affected.
Yeah,
You
maybe
say
those
something,
greens are there all the time. We just don't see them.
don't see them, and depending on, like right now I show some green auroras, and they're definitely up in Canada, and it's a very weak level going over here in daylight. But the fact that it's daylight and you're not seeing them is a good portion of it, because if you were to bring up, which I have up on my screen right now, if you were to type into spaceweather.com, I could share my screen, but this is such an easy one. Anybody that, you're going to show that thing. We can do that later. And even, let's go back to that later. Let's do the NASA one.
Okay. So we'll check this out and see what they have to say about what an aurora is. Oh.
An aurora looks like a beautiful display of lights in the sky. These are some auroras that were spotted in the sky over central Alaska.
Now, before we get any more into this, Kyle, you read the Bible quite a bit,
Yeah.
correct?
Uh-huh.
Is there any mention of the auroras in the Bible? Karen B.
Well, like it describes these colors, these specific colors as surrounding the throne of God. And so when we hear about like the throne of God above the firmament, we get this very clear picture of it being like above the North Pole or something like that. Has that been your experience too?
Yeah. Well, for me, yeah, that's about the littlest I
I'm trying
knew
to
about
remember
it.
what part talks about that and if I've got there yet.
Didn't
I'd have to
somebody
go
speak
back
of a
and
flaming sword that protected the north? And some people were
that was
correlating
the
that
Garden
with,
of Eden. The Garden of Eden was protected by the flaming sword.
and some people were correlating that, the flaming sword, with the Aurora Borealis.
That's interesting.
Yeah, I don't think that says that in the Bible, but people were making that
Yeah.
correlation.
Yeah, there's a lot of the symbols that people try to kind of look for around of what they could represent.
I'm
I'd
sorry,
have to
Karen.
do
Did I
some
cut you off,
other-
Karen?
No,
Okay.
Yeah.
I was
You're
just
good.
thinking back. I was like, did I let Karen speak?
I'll
Okay,
have to
let's.
do some further research on that and find out.
Yeah, I'd love to
I think
know
I've seen a
what.
video about that before that really highlighted all the different scriptures that talk specifically about the throne of God and its connection with Aurora.
Yeah, because you would think that there would be more mention of it. I know where the Bible was written in this, where they lived there in that part of the world. They probably never saw many auroras. But I mean, the Bible spans 4,000 years and it's telling, so I don't know. You would just think that
Yeah,
somebody mentioned it somewhere that, hey, there is this weird thing going on up in the sky. I don't know. Yeah, something to look into. Okay, let's continue.
We can also see auroras from space. This is what an aurora looks like from the International Space Station.
Sure.
The name of an aurora changes depending on its location. If you're in the northern hemisphere, it is called Aurora Borealis, or Northern Lights. And if you're in the southern hemisphere, then it is called Aurora Australis, or Southern Lights. So,
that doesn't look anything like what we see from the ground.
blaze of lights anyway. The sun. That's right. Even though auroras are best seen at night, these colorful displays are caused by our ever-changing sun. How exactly does it work? Well, the sun is constantly sending heat and light to Earth. It also sends other kinds of energy in small electrified particles, too. This is called the solar wind. Earth has a magnetic field.
Now, solar winds are real. They measure them, they have all our wind charts and all that kind of stuff. They say that's what's causing all this crazy stuff up at the top is the solar winds. And you can create wind, they call it ionic wind, just by changing, like she said, it's being bombarded by positive electrons or whatever, protons it would be, but just particles, charged particles. And those charged particles are what's supposedly creating our perfectly uniform ionosphere that's like equal everywhere. It just makes no sense. It's silly.
It's like magic.
Yeah, it is. It really is magic.
These charged particles, they can pass through like glass, can't they?
Yeah, I think a lot of the charged particles, they say, actually go through the Earth. Like the ones that aren't
Yeah,
blocked by
solid
the
objects,
ionosphere.
not
Yeah,
a
we have
problem.
things just totally constantly flying through us at all times.
Yeah.
Yeah.
So we have, at least with my model anyway, I have my sun like either inside the firmament or on the other side of the firmament. And so the solar wind can just pass right through that firmament without any problems.
Mm-hmm. All right, let's see.
Which protects us from most solar winds, but it also traps some of the electrified particles in the space around Earth. The sun does not always send the same amount of energy. Sometimes the sun has huge outbursts and blasts more stuff into space than the usual solar wind. These events are called solar storms. During one kind of solar storm called a coronal mass ejection, the sun burps a massive bubble of gas that pops.
Can we go back to that picture before you lose it? Because I want to comment on it, why it's up there, but I didn't want to interrupt her. Just pull it.
Absolutely. Which one?
Oh, just with the diagram she was showing right before it switched over right here.
Yeah.
Ooh, I'm on the I'm sorry, I'm not on the StreamYard page. Yes, that one. Okay, let's go to the StreamYard page. That's perfect. If you look at this and you look at space weather things, I want you guys to take a look at the Earth and the way they draw the magnetic field and the way that they have it going. And I want you to all think about what they're doing and cushioning it here on the Earth and the way it's falling out the other way. Go ahead and put it in rotation right now where our poles are, how that could make sense. Now that little boundary where it looks like the cornea of the eyeball going out all the way, not on the Earth, but taking your field where it's touching and going into the sun and your magnetic shield boundary. What that is when you're looking at space weather, that area there is supposedly what they're measuring where it says magnetic shield, and that for the space weather boundary. That's where when I talk about it going positive and negative into it. So there is a magnetic boundary, but it does not work very well in a heliocentric model. If you look, the model of the magnetic field is even sideways on it in order to go against the sun.
Yeah, you would think one of the poles would be here and here if it were magnetically.
If it was magnetic, right, you would, yeah, it looks backwards off of it anyway, and doing it in the way that it drips off and then does it again. If you look at it just logically, it's crazy. I looked at space weather for years and tried to figure out how it works. And in a flat Earth, if you again make Earth flat on the bottom and make a magnetic shield over the top, and you measure your boundaries, and you actually had a plane or an ionic, like what we measure, everything really starts falling into place. But even again, looking at with that diagram, it made me stop because it's ludicrous.
Okay.
And again, it's not showing any kind of twisting involved that we talked about last time with the right handle, right? And so they're just kind of like they're straw manning their own model.
Mm-hmm.
Well, yeah, that's the best way to lie, is real simply with pictures and just say, yeah, from this perspective, this is what it looks like.
And then not teach anybody about how magnetics work or electricity.
Right, and then go ahead and look at the pictures too and the way they draw it and say, why would on the poles you'd have your auroras there, even with the diagram? It doesn't, again, it looks, it doesn't feel natural, because when you break it down, you look at how magnetic fields react and do different things. And again, where is that one going? Notice how they show it going off and never ending. Magnetic fields are reciprocal phenomena. They feed into itself. You can't have it go away, just drift off. Now on here, it's nice they just cut off the string so they don't have to deal with it, but go ahead.
All right.
Earth. The sun does not always send the same amount of energy. Sometimes the sun has huge outbursts and blasts more stuff into space than the usual solar wind. These events are called solar storms.
Now, I have seen these with my own eyes, and they don't happen like this. Has to be some kind of way sped up time lapse right here that they're claiming.
Kind of solar storm called a coronal
fast.
mass ejection. The sun bursts.
Like that takes probably days to do all that stuff.
Probably just a CGI rendition of
kind
of acting out what they see.
Now, when you look at the sun and see a solar flare that's coming off of it, it's not like it's moving. It's just this weird, it looks almost like a thin, misty looking stick almost that just sticks out to the side. Now, I was looking at it from not a very high zoom. It was through Chris Van Matre's hydrogen alpha double stack filter with his solar lens that he has, and it only zoomed in, I think, 50. It was like a 50 by zoom, something like that, or 55. Not horrible, but not like the P900 where you can just pick out a part of the moon or the sun and look at that specific part of it. This was, you saw the whole thing in one thing. But yeah, you can see the little things coming off the sides and stuff like that. So solar flares, I believe, are a real thing.
They are, and they measure even, and again, this doesn't go with a big burning ball of fire. They measure the spots. The spots, it's when you have positive and negative spots next to each other. Again, the positive and the negative next to each other, that they go off to flare. And so if you have a bunch of spots that read positive, you don't have the risk of it. But they know it's a magnetic reaction. If you look at the sunspots and how they do it and getting up and looking at the areas, it's all based on magnetics. So they just tell themselves, in other words, if you look at the model, it's a burning ball of fire that have got that produces magnetic spots, and when the pluses and the minuses are too close together, they flare off. And depending on the dominance of the positive or the negative, or the cycles of it that they go, because the way that when the sun cycles overlap, which one it belongs to by or the way it comes in. Again, they know it's all magnetic, and yet it's a ball of burning fire that shouldn't have magnetic properties, really, because of the carry point. So again, it's all a mystery on how they're modeling. You isolate it. Again, I guess the people that are looking at it.
The carry point, I kind of lost me on that one.
Carry
That's
point.
when a magnet loses its magnetism. When you heat it up.
Oh,
it's around like 400 and something degrees.
Yeah, different magnets have different.
Yeah, I know what you're talking
right.
about.
But yeah,
that's the term for it.
Yeah. Okay, here we go. Let's finish this hot garbage.
A massive bubble of gas that pops and sends particles and energy zooming through space. When a solar storm reaches Earth, it dances with our magnetic field, and some of the energy and particles that zip around the magnetic field dive into our atmosphere near the north and south poles.
Why?
Particles then bump into gases in our atmosphere. These interactions result in displays of light in the sky, auroras. When the particles bump into oxygen in our atmosphere, the reaction makes green and red light.
See, now mine oxygen doesn't do that. My oxygen makes like a light blue light, and it's very hard to get it to ignite. And would oxygen be that high up in the atmosphere? Oxygen is one of the heavier, more dense gases.
Yeah, you have to be pretty low to get that, because that's, in the where they claim the ISS is orbiting with the thermosphere, which is where all of the aurora takes place, right? NASA has a video, A Trip to the Thermosphere, and they talk about the ionized gases up there. And yeah, oxygen isn't one of those gases that they really describe as being up in the thermosphere.
Yeah, I know. What is it, 24,000 feet? And like you can't survive without oxygen. People climbing Everest and stuff like that, unless you're one of those freaks. There's certain people that just can. They can, I don't know how they do it, but
I'm sure it's with a lot of conditioning and training of the meditation stuff. Yeah,
that's interesting. But my oxygen does not burn red or green. So I don't know. That's a weird one.
When the particles bump into nitrogen in our atmosphere, it makes blue and purple light. Earth is not the only planet with...
Oh my God, look how ridiculous that is.
There's a video, I think Jaron talked about it a little while ago, or it was some time ago, and what was it? Potter's Clay. The Potter's Clay did a video about it as well, about how they took a picture of Jupiter from a long time ago, and then they just kind of copy and pasted this image of aurora on it, and it was just super, super memorable.
Yeah, the spot was the exact same.
Why did they have to do that?
The swirls were the exact same. Wasn't it like 4 years later or something like that?
Yeah, it was like forever ago, and all of a sudden, here, we're going to put all of the storms in the exact same place, and then just do this copy and paste job here. And it was
that's one of those David Weiss borrowed. He would bring that up all the time. Yeah, look at Jupiter 4 years later, and it's the exact same thing.
If a planet has an atmosphere and a magnetic field, it probably has auroras. For example, NASA spacecraft have captured amazing auroras.
Wait a minute. Every planet has a magnetic field, right?
Should.
That's what I mean. That's what NASA says. It's either Secchi or Soho was reading the magnetic fingerprint of the planets. That's what it was showing. That's how it knew where they were, by picking up their magnetic fingerprint or something like that. Yeah, I used to look at them every day. So yes, every planet has a magnetosphere or whatever. Well,
A
planet,
field.
right? Yeah, a field to it.
But
See,
why
that
don't you
makes me
see me on the
wonder,
bottom here?
is any of that data even real? It makes me wonder. Is it just nonsense that they're giving me, or are there these things up there that are measuring magnetic fields of objects that are up there floating around in the sky? I would
I
love, those are the
I
questions I
think they
really
do
want to
have
know.
magnetic fields though, just because sometimes when you look at them, you can see like the red and the blue, on them in like the aura of the body when you're looking at it. Like to me, it looks like, you know, they're showing polarity, which means it has a field.
Now this what I am reading from the book of Google, and I asked, do all the planets have magnetic fields? And it says, now this is where I'm not happy with it, because they're saying probes, not that they're measuring it from Earth. So that's what I want to know, is how they're measuring it. And they're saying probes, which I don't trust probes, but I do trust people when you have scientists on the ground from all different places taking measurements in the field with equipment, with stuff they're used to using. I do trust numbers like that. Like I've actually been up to Boulder and I've seen how they've done some of the things. But probes found that Mars and Venus do not have a significant magnetic field. Jupiter, Saturn, Uranus, and Neptune all have magnetic fields much stronger than that of the Earth.
So you'd think you'd
Uh,
see a lot more. Yeah, but all of
mhm.
this, notice in this picture here, all of that aurora is the same color, which I think is pretty interesting.
And I remember from my childhood and different things, and I think it's still a thing going now, that Mars used to be inhabited or whatever possible, and they got stripped on their magnetic field. And that's always been a big conspiracy too with things, is that like maybe I don't think there was life on Mars and doing that, but I do know that they pushed on the magnetic field on Mars with saying it was stripped, if anybody remembers that. It's silliness.
Yeah.
All right, let's finish this up. We got 20
Auroras
seconds.
on Jupiter and Saturn. Learn more about our planet and our solar system at NASA Space Place.
Thank you, NASA. Oh my goodness.
Yeah. So one of the big mysteries about aurora is this river effect that you're looking at right there. Because when I think about ionized gases, I'm thinking about the colors of sunset. You see the whole sunset turn pink, right? The whole sky turns pink. It's like a sheet, but this is like a river. So
Yeah,
why
that's
would that be the
amazing.
case? Especially if it's coming in at a perpendicular. This is all that doesn't look like a perpendicular stream like NASA was claiming there, right? This looks more like a horizontal stream.
Yeah, absolutely. This doesn't look like water going this way. This looks like it channeling itself right through here.
Yeah,
It's
that's
not
definitely
like
not a
flowing.
perpendicular beam from
No.
anything going on.
This is what they are calling the Australis from the southern version, from the International Space Station. Yeah. Okay. They say, okay, here's why auroras on Earth are different in the north and south. Now, well, let's see what they say. Don't precisely match. Ever since scientists realized these two celestial displays don't line up, they've been trying to sort out why. So even they admit, this is space.com, that the northern lights and the southern lights aren't acting, in unison. Like when this happens in the north, we get the northern lights. Well, when this happens down in the south, we're not getting the lights right now. But when this other thing, when it's this way, it's happening in the south. So there's a difference here that's not corresponding, kind of like with same thing with the plant growth. We have plant growth that goes way up north past 70 degrees north. And then you go down south, and I think it's 55 south latitude is the last like shrub type thing. And anything below that is like seaweed or like moss that grows, and that's about it. You don't get any plant life really. Definitely not shrubs or trees or anything like that.
Yeah. Kind of thinking back on this whole stream here, I'm thinking about jet streams. I was just like, that looks more like, illuminated jet stream. It's kind of what I'm thinking of. If you scroll back up and take a look at that, and yeah, so
Yeah.
that's kind of more of what I would expect.
I wonder if there's I was going to say any correlation with the currents in the water beneath, but no, I doubt that.
I'm
So
also
now
kind of thinking about plankton and about how if you've ever seen
they
an
light
ocean
up. Yeah.
and that lighting up, and so maybe it's kind of some kind of a atmospheric
Yeah.
effect, kind of like that, something similar.
Okay, where is the camera that's taken this picture? Is it?
The ISS.
It's,
Yeah.
and Jana, who's in the chat, had a really fun question for me the other day that even with the Soho pictures and the things like this, I thought it was valid. Maybe you guys have thought about it and I haven't. But her thing is that, okay, those pictures from Soho and all of these pictures were taken in those cameras. How are these cameras working in space if they're getting bombarded with radiation and getting all of this stuff sent on them? How do we get the images? And I thought that was
That is a great
great
question.
question. Shout out Jana in the chat. So that is with any of these things, it's something to think about. If, like, again, the shielding to hold it from the radiation, you wouldn't be able to have your lens open, I don't think. And so how is this equipment functioning under these conditions that they're putting it into, when we all know how finicky cameras are to radiation and to temperature and to all of these things?
Yeah, I keep thinking Irio is our balloon guy, and we got to do a fundraiser or something at Fotoberfest and send him to Alaska and see what he can observe of the aurora during the wintertime like this.
Yeah. Yeah, no doubt.
That'd be a pretty cool thing to do with the balloon.
So they're saying now a team of researchers thinks, that's one of those keywords you have to pay attention to when reading these articles, thinks it has found the reason. Asymmetry in Earth's magnetic tail. But what's stranger is the asymmetry is caused by the precise inverse of what scientists expected. That's not very... Okay, let's see. The reason this is exciting is that earlier we haven't thought that the asymmetry in the system enters the magnetosphere by a mechanism called the tail reconnection. Oh my goodness.
The hell?
It's kind of really vague in a way. It's hard to just to
Magnetic
visualize what they're
tail.
talking about. They're saying that it's different, that the aurora is different in the south than it is in the north, and they're kind of painting some really vague pictures as to why it might be different.
Oh my goodness. Yeah.
They're definitely kind of sending a lot of signals as to saying they don't really know, but they expect one thing, but they're getting different results. And so I'm just seeing a lot of confusion here.
Yeah, there's... Wow. So Earth's magnetic tail. So which is created by interactions between our planet and the sun, they say.
I'm thinking
Earth.
back to their diagram and how the only tail I saw on the diagram that Cami was pointing out, showing the magnetic fields, there's the side of the Earth that is pointing towards the sun, like on the equator, and then there's the opposite side, and that's where you get the extended magnetic field that's kind of like the shadow, the Earth kind of shadow from the sun, and that was kind of what they're talking about. But when it came to like the North Pole and the South Pole, I didn't see any tail in their magnetic diagram there.
Yeah.
So I don't know what tail they could be talking about here.
Well, they're saying that it interferes with the magnetic field the Earth produces, the solar winds do, squishing it on the daylit side of Earth facing the sun and stretching it on the night side facing away.
So I was right. That is a tail that they're talking about then.
Yeah.
On the equator, not on the poles.
Yeah. So yeah, why would that affect the poles? Yeah.
Yeah. And so they're saying it has to do with the tail, which is on the
Is what
equator.
scientists had
And that's
thought
why it's
caused
the northern.
non-matching northern side of the magnet that's in darkness, and auroras are only visible at night. But instead, the team behind the current research realized that the solar wind's magnetic field doesn't always line up precisely with Earth's. When it's skewed, it introduces asymmetry between the north and south poles into Earth's magnetic field, and that in turn causes the mismatch between the northern and southern auroras. Wait a minute, what? So
Doesn't
the
always line up.
solar winds doesn't, when it's skewed, it introduces, okay.
Yeah, I'm still not getting a clear picture as to why you can't see aurora during the daytime everywhere, like on the globe model. That just seems off to me. It's only in this one particular location, and yeah, those electrified or the charged particles aren't hitting the atmosphere in the right ways like everywhere else. I don't see why.
Yeah, it doesn't, I mean, the light particles all come in at 90 degrees, right? Wouldn't solar wind be coming in at 90 degrees as well? I don't know.
Yeah, that's what you see it. You see it. It should be that way, at least according to my understanding. That's the only way I can visualize it. And no, it's only if it curves around and hits it, does this whole like 90-degree turn there, pretty much.
And then they go on to say that understanding the auroras themselves isn't vital. Yeah, because they realize that this was a load of hoo-hockey up here. As auroras are just symptoms of how the sun affects the Earth through a set of phenomena called space weather.
We can't explain it, so it's not important. Let's try to sweep it under the rug as fast as we can.
Well, yeah, I mean, they talk about, oh, this next solar flare is going to come and knock out all electronics on Earth. Wouldn't it be nice to know when that's going to happen? I mean, if you understood this stuff a little more, maybe you could. It's not vital, though, I guess, right? Having electricity and all that kind of stuff. So, yeah, just space.com. Another one of those articles where there is no anything but just thought experiment right here. This is just thinking out loud. There's no real testing done, or they're just looking at old data and drawing correlations out of it. That's all they're doing. We
Trying
can,
to sound as official as possible
yeah,
without really providing any kind of substance to their work. They're not really sourcing any other things. Yeah.
Don't lose that page right now because it even tells you the quality of the space star. Meteorite that crashed to Earth 35,000 years ago, carved into Arrowhead by Bronze Age hunters. There you have it.
Oh my goodness.
It's a fact, Jack.
All right. Well, here we go. This is STEM learning. Christmas science, the Northern Light, displacement of copper by aluminum. Do you want to kind of give a brief summary on what he's going to show us here, Kyle?
Okay. Well, you can kind of skip to like halfway through the video. He's going to put some aluminum and copper into this tube, and he's going to put some chemicals on them to make them oxidize in order to get a whole bunch of hydrogen, and then he's going to ignite that hydrogen, and in order to simulate his aurora.
Well, that's not even what they're even claiming is going on, is it?
Yeah. Well, when I was looking for aurora, my big question was, has anyone ever simulated aurora to verify this is what is causing the aurora? And so if you want to do that, that's what I'm going to look for, is a little demonstration that this is the fact that, or this, sorry, I can't talk straight right now, but yeah, a demonstration saying this is how it is.
Well, yeah, there's a reason why nobody, and they've been trying to do this for a long time, to actually recreate an aurora on an object. And they can't do it because electricity doesn't travel in a vacuum. That electric field isn't going to get from its point source to the object because it has nothing to travel on. And that's another reason why they can't explain auroras, because it doesn't make any sense in an electrical universe, the way they have it all set up. But yeah, even the Electric Universe guys, I don't think they have a definitive answer on what they say the aurora is. But hats off to this guy. Anybody who's mixing up chemicals and, blowing stuff up, I'm all for stuff like that.
Yeah. So if you go for a little bit more hit, he's going to stick this little ball of
So we'll get
aluminum foil in
aluminium
there.
chloride. Aluminium
Here,
is
we'll-
more reactive in the reactivity series than copper chloride. So the aluminium will displace the copper out of the copper chloride, which means we'll get aluminium chloride forming and copper as a solid metal forming. And we'll be able to see that at the end of the reaction. Because we've also got that hydrochloric acid there to get rid of our aluminium oxide layer on the aluminium foil, we'll also have hydrogen being produced. Now, the hydrogen is what we're going to ignite to create our northern lights, to light the way for Santa. So I'm going to add the aluminium foil into our solution, and you should start to see it react
They're
quite
going to start
quickly.
bubbling.
Just give it a stir. You can probably already see it going quite dark.
Oh, yeah. Wow.
And can you start to see the hydrogen coming off as well? Now, the best way to see this is if we turn the lights off. Now, what we need to do is ignite the hydrogen that's coming off, and we should see our northern lights, which will light Santa's way to our house to deliver our presents. Just going to ignite. And there's our northern lights.
Kind of
Yeah,
a bluish
no,
color.
that's not Northern Lights.
Not very
No.
green, but it does have the tendrils to it, and I thought the tendrils were really that was the closest thing they got to Northern Lights here is the flickering flame effect.
It's like I said, it's impossible. They've tried and tried and tried to do it with electricity, and they just can't do it. They can't recreate
the
this.
closest I've seen of that is those plasma balls and the Tesla coils that they do, where you touch it and you see like the simulated
Mhm.
lightning kind of effect. And so I think that is close to it, but it's still kind of off. And
Oh yeah, way off, because that's a discharge right there between the two objects. This is sending something like almost through induction and creating enough of a charge to actually get the gas just above that ball to start glowing.
yeah.
Yeah.
So the interesting thing about this video here with his simulation of Northern Lights, as he claimed, is he had to take a bunch of the really hard metals, copper and aluminum, in order to get this off-gassing effect. And so I kind of thought about that and was just like, if that's what it really takes, then is this kind of evidence for a firmament? Needing the hard metals in there. Although I don't really look at aluminum as a very transparent metal or anything like that. Unless you get into Star Trek, I think it was transparent aluminum that was the magic thing or something like that in Star Trek. But
Did you know at one
Yeah.
time aluminum was worth more than gold?
really?
The Washington Monument was tipped with aluminum because
Wow.
at that time it was built, it was worth more than gold. I forget the gentleman's name, but he figured out how to process aluminum in mass quantities. Before it was just made in labs. And now they could produce it on giant mass quantities, and the price of it just went bloop down to like nothing. Now it's one of the
Wow.
cheapest metals out there. Yeah. Okay, this one was cool. Trying to create it in a microwave oven. What do you think about this one, Kyle?
Well, we'll watch it and then we can talk
Okay,
about it.
alrighty.
Welcome back, folks. In this experiment, we're going to
Real quick, we'll give a shout out to SciTube HD. Not quite. That should tell you exactly how well the experiment went, or the test, yeah.
try and create Aurora Borealis or Northern Lights in a microwave oven using low pressure air. So what I have here is a round bottom flask with a stopcock. And I'm going to evacuate the air from this, which means that there'll be low pressure air in this. And I'm going to use this two-stage vacuum pump. And I'm going to test whether the pressure is right for ionization with this small solid state Tesla coil that I'm going to put it near to. So let's begin. First of all, let's get the vacuum pump going. Let's start to evacuate the air. Let's see if we're getting low pressure air. There you go.
Now let's test to see if this is possible.
It's lighting
Wow,
up, but that's
that's
the sheet
amazing.
effect. That's the sheet effect. With that whole thing, that concept, the whole night sky should be lit up, right?
Mm-hmm. Yeah.
It's not the tendril that we're seeing, the river.
Does he have water in there as well?
I didn't see. It does look like water.
Cup of water.
Really cool. It's ionizing air in a microwave. Basically, Aurora Borealis in a microwave.
Yeah, if that's the case, then all of the gases would have to like clump together way up in the
Well,
thermosphere.
thanks for watching
instead of
this
spreading out.
microwave demo showing plasma equivalent to Aurora Borealis.
Equivalent? I don't think so.
No, definitely a lot different looking. But yeah, here's the one I was talking about.
Experiment that's actually over 100 years old. The Plantarella was originally designed by a Norwegian space physicist called Christian Birkeland, who in 1899 led an expedition to the top of an Arctic mountain to study the Northern Lights, or the Aurora Borealis as they're also known. Birkeland was actually the first man who really started to understand how the auroras were formed, and back in his laboratory in Oslo, he built this experiment to show his ideas to the world. This particular Plantarella was designed by CNRS in France by a French scientist called Jean Lilliston. And it's a vacuum experiment. So what we have here is a vacuum chamber and a vacuum pump, which is a bit like a Hoover home. And the vacuum pump sucks out most of the air out of the chamber. Not all of the air, but most of it. So it's recreating the...
Yeah, that's the kicker. Most of the air. So it's not anything like the measurements that we get up there. When people put it in there and turn the vacuum down all the way to as low as they can get it and try to recreate this, you don't get this right here.
Yeah, and that's a pretty blue. It's not very green, and it's not yellow or magenta or anything like that. Yeah, I guess that one's more magenta.
Yeah, beautiful. Yeah, this is the one I'd seen. But the thing was that it's not even near a vacuum. It just turned down, you know, a bit.
Trap
Most
onto
of
the
the
Earth's
air.
magnetic field lines, and they get funneled into the northern and the southern polar regions. And when they get to the northern and southern polar regions, they collide with the gases that are there. And what they do, they excite these gases, and they actually give energy to the electrons within them. When these electrons relax, they give out light at the characteristic frequencies, thus creating the aurora. That's basically how...
See, now that's what I want to start playing with next, is different frequencies. Do they make different lights?
Yeah, well,
Like
this
with the
I'm
same
not
colored
I'm definitely
gas?
not seeing the tendrils.
Yeah, no, not at all. That looks like it's almost covering the whole thing there.
And over there on the left, yeah, it's just kind of like bleh, it's just a sheet. Yeah, sorry, I didn't mean to interrupt you. On you were talking about frequencies, about playing with different frequencies.
Well, yeah, like the star in the jar, especially. They say when you do that, it you can create different colored stars by manipulating what frequencies you're using and stuff like that. So I'm wondering if the gases that I have, if I could get them to change a different color, if I messed with the transistor on my
That would be
Tesla coil.
interesting. Yeah.
If I change it to a much different frequency, can I get the colors to do something different? I have to be careful with that stuff, though. See, now my one Tesla coil didn't do much different than the other one. It just didn't do it nearly as bright. But neon always fluoresced neon, like that orange color. So I'm not sure. Maybe this is what I'll start playing with. I've been looking for something to experiment and play with. The Tesla coils, though, I'm scared of them, man. I'm scared to have them around anything. But now that I have the garage cleaned out and I could put it on the ping pong table, and that shouldn't be near too many things.
Makes you wonder how Tesla did it, right?
Yeah, well, Tesla didn't have computers in every room of the house and stuff. I have,
Yeah.
things I can destroy
Yeah.
that I don't want to destroy at all.
Maybe building like a big Faraday cage all around it when you do it. Would that do it?
It would help. It
Or to have
wouldn't.
like a lab like Tesla did, where you could do stuff in a big room.
Yeah, just a shed. Just give me a shed. I'll be happy and content. One of these days.
Yeah.
So what was this? Was this something that you had brought in, Karen?
Oh no, I dropped that in, and that was just the information on it not being a superconductor, Zach. That was just part of our other superconductor conversation. Off topic
okay.
entirely. Close it up. That was just me going nerd.
I was looking at
Okay.
superconductor stuff though, but I didn't mean to put that in today.
So here's a question for the chat. Have you ever seen like the really big magenta and yellow colored aurora in the north, or is that just a southern thing?
I don't know. Let's
Because
yeah.
I showed you that picture of the side by side. You always see really green auroras in the north, but then you just type in southern aurora, and all of a sudden it's yellow and magenta and totally different colors.
Should have had something up for this. Southern Aurora.
There you get those different colors there. That looks pretty different than
Wow,
the
yeah,
northern lights.
man, that is beautiful. That looked more like sunset type colors.
Yeah.
That's a trip.
And yellows.
And it doesn't
Although,
appear to be as tendrily as the north.
And then what's north? Green. Green and pink are opposites on the color wheel.
Mm-hmm.
That's fascinating.
Our universe is definitely color coded.
100% Karen.
Man, that was beautiful. Wow, look at that one. Yeah, I really don't. I believe it's definitely electrical magnetic interactions going on.
Well, there's some green down there.
90 degrees south. Sure. Oh, wow. Now, I've never seen the sky quite like this, but in New Mexico, you can see like this rift.
Really?
Yeah, when you get up into the mountains, of New Mexico, it's so clear and there's like nothing around for,
You can see stars like that?
Not quite like this. You don't see all this gas and stuff in here,
but you
the
can see the
stars are
Milky
that
Way.
dense. Yeah, the stars, you can definitely tell there's this big band of stars like right here, like 10 times more dense than the rest of the sky. It's just gorgeous. So yeah, this one, it's getting all kinds of different colors. But yeah, like you said, Kyle, it's even at the South Pole here, it looks like it's, wow, look at that. But yeah, until we start getting actual data that we can trust about what's going on in our upper atmosphere, what the
I have a hard
sun is
time trusting
actually
this just
doing.
because of the clouds.
Well, yeah, anything coming from the South Pole, I have trouble.
Yeah.
This right
putting
here
any faith into it.
Doesn't look like as, I don't know, it looks like a very much a enhanced color, or it does. Again, seeing the stars behind it and everything unfold over, there's something that doesn't feel.
Now this is Sky News Australia, I think, or ABC Australia.
Okay, that one looks a lot more green, obviously, but
That one there, the one that was the news one, again, it looks foggier and you didn't have quite the, well,
Wow.
There's some
Perth
really bright
observed.
colors over there.
Yeah, see, I'd have to see something like that for my eyes to believe it.
Yeah. But
I've
I've never
heard
heard of
too.
any of these colors in the north. I only see that kind of stuff in the north.
I've heard that it's more colorful in real life too. Like the cameras can't pick up all the colors that you see in real life.
Yeah, I've experienced that. Cameras just don't do it justice, like all the time when it comes to sunsets.
Oh, yeah, no. That's because it's there for you, not for other people. Humans have tried to capture things like that, but you don't see it.
Yeah,
You know, you take a picture of anything and it's never as glorious as when you were standing there taking that picture.
I like that way of perceiving it.
Yeah, that was for you. That was God's gifts to you. So yeah, I mean, as far as auroras go, it's really hard to put a finger on anything without actual data from up above. And I mean, it definitely is electrical. It's magnetic. I
I
You
mean,
can
what would
almost
you
see
even
it.
do to try to like study that? Like, would you bring like magnometers or something, or things to measure like the charge in the air? Is that even a way you can do that?
No,
Like,
they have so much trouble trying to measure the electric field at high altitudes. They can get a wire from the ground up into the sky about 2 kilometers, and then it explodes.
Wow.
It just evaporates. The wire just and it's gone.
wow.
Yeah, it creates a bolt of lightning, and it just is gone. So getting an actual measurement of high altitude anything has never been done with certain, you know, accuracy, precise, like this is how much electricity traveled through this wire. There's too much at 2 kilometers, let alone, 30 kilometers up, something
Yeah,
crazy like that.
it's another one of those bottom of the sea kind of. We barely understand any of this of what's going here on Earth, and yet NASA is trying to dump billions of dollars, and oh yeah, we understand all this other stuff about all these other planets, right?
Nick and Chad asked, how do planes not explode? Well, the plane is not touching the ground, so it's not electrically neutral with the ground. They do have to discharge a lot of planes when they come down. I mean, they're landing on their rubber wheels, which is okay and everything, but a lot of times they'll have to take a guy and go up there and like touch it with a grounding rod. They used to do this like on every plane back in the day, but now they have these little spikes that come off the wings of the planes and the fins and everything that help dissipate that electricity. Remember, we've talked about it in the other Globebuster techs. A point will give off a lot more electricity than a flat edge. So that's why on all airplanes now, coming out the backs of them, the big commercial ones, they'll all have spikes just sticking out. And you're like, well, why would they have just that spike there? Is that aerodynamic? No, it's to let that electrostatic potential that's gathered on the plane flow off of it faster.
Yeah, I remember in the Army learning about airborne assault, where they're rappelling out of helicopters, and how there's a certain part of the helicopter you don't want to touch, otherwise you'll be electrocuted to death, just because of the electrostatic charge.
Yeah, you have to. Yeah, it used to be a lot more common in airplanes to where they'd have the guy down there with the thing discharging it, like everyone. But now they found ways to battle that, to get rid of the electrostatic potential before it even gets down to the ground now. They've gotten a lot better at doing that. And it's as easy as putting things on it that are pointy. It's really that simple. So you don't hear about it as much anymore, about the electrostatic potential difference, but you can still find the articles. They'll still tell you why. Let's see here. We'll just go look it up. No, let's close that out. Surrounded. Okay, blah, 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 blah. Is there such thing as on what? No. Airplanes.
The way
in
you're
the
talking to yourself
air.
makes me think of Jaren right now.
What the heck? I just looked this up. Static wicks or static discharge wicks are devices used to remove static electricity from aircraft in flight. That's Wikipedia. I can't stand Wikipedia. They keep on talking about electrically powered planes.
Because they want to push everything to be electric
Yeah.
now.
I'm still laughing at how Wikipedia now has to put their little warning banner on the thumbnails, the video thumbnails themselves, because people are still watching the Flat Earth content from outside sources, like the Clock app, for example. And so it's kind of their one way of getting them.
So yeah, it's just talking about the different. This is from Aviation Hunt, aircraft static discharge. Yeah, it's not nearly as bad as it used to be. Steamering, electrical discharge that may tail from the aircraft, dielectric surfaces such as composite randoms and composite winglets, blah, 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 blah. And they've been reduced by coating non-conductive areas with high resistance paint that allows the charge to be bled from the airframe. So see, they've come up with a lot better ways of getting this stuff not to happen. Because we do use a lot of electronics on all these planes now. It's not like back in the day where, you only had your artificial horizon and maybe a couple other things, and that was like it. Now everything is electronic, everything. Your seats are electronic in half of them now. It's crazy. So they really have to protect themselves from this. Okay, static dischargers, how it works, blah, 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 blah. Well, I'm thinking short show tonight. The Auroras, it's kind of hard to state anything definitive about them yet.
There's
I
so
wouldn't
much we don't
mind.
know about them. That's the fun part about it.
I wouldn't mind just walking through the space weather things and having people look through some of the data and stuff, looking at it if that works for you, or we could end now. Do you think that's too confusing?
But here, you control it. Because I don't go into
Okay.
space weather.
No,
so
I was
you
going to.
share with me.
I can present. No, that's fine. So let me see. Share screen.
Yeah, that I don't think I'm buying that. It's
Well, I'll show you the things that.
a picture. No, I'm talking
yeah,
about what
okay.
I'm showing on screen here. That is neat though. And that is a lot of the times how they would look, how they come off with that. It's almost like a wave, like two lines coming through and they're like waving. Yeah, it's amazing how they do it. Just beautiful.
But
Okay.
the magnetic fields themselves, do you think that that is a magnetic field itself? It kind of reminds me of a little bit about some of the weird wavy areas. But when I think about magnetic waves, I don't typically think of them as kind of moving all over the place. But with the right-hand rule and the twisting of it, magnetism itself is a motion, right? That's kind of it's a circuit.
Yeah.
Oh, that's so funny. You said emotion, and I heard it as emotion, and I was trying to grasp the concept of it being emotion or emotion.
Oh, not an emotion.
That's what I thought first too.
In motion.
Oh.
A magnetic wave is in motion, but I don't think of a magnetic wave as kind of moving around all over the place, like tendrily. You know what I mean? But when I think of a magnetic wave, I think of something a lot more fixed. Maybe that's just because I'm more familiar with ferromagnetism, like with a magnet on your fridge, since the magnet
And you're dealing with
around or moving around, it's going to have a much more fixed pattern.
I think it's trying to magnetism is the counterpart of what the electric field is doing. So when you have a charge, that charge that's moving, you're going to get your magnetic field. Well, the magnetic field, I think, is just that charge is the action, and the magnetic field, I think, is the reaction to try to turn the ether back into its natural state. So you have this action happening, and then the magnetic field at the exact same time is trying to convert it all back into being neutral again, because you had this difference right here, this potential difference. So it's all that other, as that, like, say it's a spaceship, right, or an airplane flying through, and as it's a charge. So as that spaceship is flying through, the air is going to take its little, we'll say a contrail, a real one, and it's going to dissipate it and turn it back into the air and not that weird thing that it just was. That's kind of like an analogy I would almost put on it. Electricity is the disturbance of the ether, and magnetism is it trying to reset it back to its original state. It never happens because we're in this ever-moving present electrical field. It's always around us, always happening, always taking place. So it's not like you can turn off magnetism because you can't turn off the electricity that's taking place.
I'm thinking of, like, if you've seen a trail of food coloring in water and then just kind of put your fingers through it or something like that, it kind of moves around, something like that. It's a little bit more fluid, and that's kind of showing me a lot of fluidity in the aurora. But if it was directly because of the magnetic field and it's kind of flickering and moving kind of like a wave, then if I were to pull out my compass, I would expect my compass needle to be flickering back and forth, you know?
All right, Cami, what are we looking at here?
Okay, you're looking at, this is off of spaceweather.com, and this is just their aurora forecast right now. And you'll see that right now there is, if you look at the code probability of aurora, the light green 0 to 1 or this and going to red, you'll see that right now there's very low probability of aurora. And if they get any, like right here in Greenland, it's not going to, this is a key, not what color the aurora is going to be. This is only a key that says that
how probable it's going to
right, and exactly. So it's not all that much. This will, get heavy, work its way out. It's a fun thing.
It's not saying the aurora is going to look like that.
Right.
It's kind of the zone.
No, but this right here, this would be if this would be our heaviest area of seeing, probability of seeing an aurora. So if you wanted to see one right now, this would be your best zone to be in right now. But what's going on? You might see a little bit, but there's very little going on in the air. So it's not going to be intense auroras. For the next, our lead time is 75 minutes. And I think they pretty much do a good idea, thing on that. But you'll notice it goes all the way around. You'll also notice some fun things. It's not circular, which is interesting. And
it's not a perfect circle.
And it does not center around our pole there. What it does, I've held out rulers to my screen with the auroras and positions from all over. And no matter how many times I do it and draw the lines on the screens and do it, it tends to come out right around Thule Air Force Base, which I always thought was interesting because Thule has got such, we built as America an Air Force base there, but this was Thule talked about. This is supposedly where you would get onto the Rainbow Bridge in the Nordic mythology, and that in order to get, up to and to ascend in that. And right now we do have that we own that area. As when I say we, I don't mean me or we, I mean the United States has a military base there, took over about at the lands, and they have over the last few years been very interested in purchasing all of Greenland, which is just a fun side note. But I think it's important to look at the auroras and take note of what's really going on. And with the helio model, say, why would that be?
Well, yeah, wasn't Donald Trump trying to buy Greenland?
Yes, he was. He was in very hardcore trying to do this. Let's go over Antarctica and look at their
question is why.
Why? And again, when you look at the southern ones, if you look at it, these ones I need to start looking at more because I really it doesn't default there, and I don't usually go. But you'll notice again, it's not defaulting
It's all of a
over
sudden, oh, now it's a perfect sphere, or sorry, the sphere, circle.
this is more of a circle than there, so it's more circular, but it's certainly not doing it over our geographic pole. And if you look at this page here, and again, I call it a mixture of good and bad and different things. You'll get some things. You have a lot of people taking data, the solar wind speed and the density. I know that they take those from locations all over. I think a lot of this is what they do with a probe versus what the scientists can do on the ground, and they mix and match, and they give them a different baseline to work with. Again, your space weather people, they know your space weather one, the sun remains relatively quiet for the third day in a row, despite the presence of multiple large sunspot groups. They say that there's less than a 15 chance because, again, these are not contrasting. You can look at the magnetics of the spots and see that the dynamics of them and that magnetically are not strong. It's when you get the positive and negative next to each other in there that you'll get the big flares going off. So they can look at that. They know they read the sun as a magnetic reading. Everything they do about it is with every terminology is done to do it. I think that what you were talking about, Zach, as far as electricity and the magnetics, it's an interesting point that magnetics, you can have what Kyle is talking about, like your static magnetics, and that's what we're taught, and we're really pushed that. We're really taught the ferro action of it. And again, I think this is very, very much by design. But what's interesting is we can have a static or a magnet without an electrical field, but we can't have an electrical field without a magnetic field. So your byproduct can last. And again, what we feel that the permanent magnets are and how you make them is by running electricity through ferrite materials. So if you run electricity through ferrite materials, you can make a magnet and it will hold the magnetism, but it doesn't happen without running the electricity through it. It's like a residual byproduct of how it affected the material, but we cannot have electricity without presenting the magnetic field. So we're taught that the magnetics are the static, ferrous, sticky thing, and is static when in fact it's not. The magnetic field, again, anytime you have electricity, you create a magnetic field. So many things create magnetic fields, and it is very dynamic and in motion. If you were looking at what this page is talking about, the interplanetary magnetic field, they take measurements. On the measurements and on the different readings they get, you will get a correlation to equipment going bad, radio blackouts and things with the things. We do know that this that when auroras go down, our KP index and things go up, we do know that we have, this is a very quiet number, 2.67. Remember how I told you I would alert at 5, and 5 was a low alert that we wouldn't see anything in Colorado at a 5, but I mean, I put my alerts really low to try to catch anything. But they do take things and we do get real data from it. And so again, it's to me, discriminating between what is the direct data taken by scientists versus the probe data fed to the scientists, that they would of course treat the same. So there's
the important thing here that we're talking about is there is a for sure correlation between sun activity and the aurora. There is
100% easy way to read the sun activity.
It goes right along with the sun solar cycle, the 11-year cycle where it,
right.
It gets lots of sunspots, and then 5-6 years later there's a lot less sunspots, and then 11 years later from the start you're back to having a bunch of more sunspots again.
I think the sunspots increase when we have solar eclipses. I've noticed.
Yeah, there's so much research that needs to be done still.
That's all part of the fun of it. So kind of knowing.
I know, it's just such a shame that we can't trust a lot of the data that we pay for.
That we pay for
all of this stuff. Wouldn't it be nice to get the truth?
Yeah, it's important to realize how much we don't know, because NASA, they really try to just stuff it down our throats. Oh, we know everything. There's nothing left to be explored anymore, right? But that's totally like bogus. It's just totally bogus. There's so much more out there to be explored. And
Big
this
shout
is
out.
one of them.
Yes. Big shout out to Joe Mama for the $20 super chat over on Rockfin. Says, okay, I'm here now. Let's go ahead and get started. Thank you, Joe Mama.
And we
then
appreciate
Murray
that so
Cole.
much. And we appreciate the new members so much. Welcome to our channel, and thank you so much for signing up on it. So you're right, you do, but you do have the data. It's collected, and it really does work into real results that make sense in a lot of ways. What I have to say is following space weather for probably like 25 years, 30 years now, if not longer. The one thing I can tell you is I followed it and I got so immersed with it because I could not solve it, and was trying to understand exactly how all of it worked. And somebody put in Ben Davidson or Suspicious Observers, that when he started, I was already deep into it. It was like, oh, good, somebody is putting out more stuff, and it was like having somebody to talk to before he went completely paranoid. We won't
Fear
even go
porn.
there. Fear porn, yeah, until he went complete fear porn with the things. But what I can say is I can say that on a flat Earth, a lot of this makes sense. And I would see why they would want to have scientists collecting the data, because I'm telling you, up at the top, they know the Earth is flat. And so they do need people collecting and taking the data in. And again, as long as they can keep them applying it to a different baseline, it's harmless. And then they can, again, it gives them lots of room with probes and pictures to throw in more effects to validate their model. But I do think a lot of the readings we take are correct, and especially about when we're talking about our interplanetary magnetic field, I think it is. It's a play between the two magnetic fields. The Earth's magnetic field and the firmament magnetic field would make sense, or what they're calling the ionosphere, and we would call our Gaussian plate, or another dielectric inertial plate. Again, a magnetic field to play with. It's a play between the two fields, and it pulls to the north and the south, and it's very, very dynamic. And with the dynamics and of the things you look at too, you'll see that as it plays, it has an effect on people, their emotions, electronic equipment, so many more things than we say. And yet, again, in their model, their model of their molten cores in the middle and spinning around are supposedly creating a dynamo that makes the electric current, that makes the magnetic field. But again, it would cancel itself out in their science. They're not looking it through with your electric dynamo, as far as I'm concerned. And then when you're putting it on all of the different planets and that, what about on the gas giants? I was reading Jupiter's got the strongest. They're saying on the gas giants, they have the strongest magnetic fields. They're now putting metal molten cores to our gas giants.
So
I looked at that.
ridiculous.
So they said that Jupiter's molten spinning core is making it the strongest magnetic field at all. Again, the things that they're just right now even having to invent to come up with answers to their questions. I find it a fascinating place to do, because there's a lot of data to get, not
So
just on this
how could
page.
they consider that a gas giant if it has a molten metal core now? It's not.
Here,
It has a very large atmosphere, maybe, but a molten metal core means that it's a solid body, or at least a liquid body. It's not a gaseous body.
let's go to Quora. Which planet has the strongest magnetic field? Jupiter has a magnetic field that is 19 times stronger than the Earth. As Jupiter spins, the swirling liquid metal ocean creates the strongest magnetic field in the solar system.
Liquid
Yeah,
metal
but you
ocean. Wow.
can't take Quora with a
That's
grain of salt.
so contradictory to what we know about how things work.
Yeah.
Right. And
I'm
here,
still looking at
this
those
is another one that we can
magnetic
take from Quora,
fields.
but they're going to do it to look it up. Sorry, this is a favorite of mine. Can a magnetic field flip, and how? Of course, and it's happened to Earth many times. It will happen to Earth many times in the future. We can tell this is happening by looking at the bottom of the Atlantic Ocean, where underwater volcanoes push magma up and gradually push the continents further apart. Okay, guess what? In the Atlantic Ocean, you know how we age things going up, the further you the deeper you dig, the older it gets. In the Atlantic Ocean, it's different. You read it that the further away from here, it's newer here and older here, and the up and down have no bearing whatsoever in the Atlantic Ocean, unlike other places where you measure going up and down vertically. Here it's a horizontal straight measure, and you can tell by these strips that, oh my gosh, of course we've had to flip at each one of these strips. It couldn't be the creator's design to maybe run, again, your baselines. If you think of tracks, and as to me, this looks like a created tracks maybe for our different things. They're part of the plan is what it looks like to me. It doesn't look like a field trip and a pushing and that. It looks like part of the plan, but that's just my crazy opinion.
I remember looking up like the Google Earth pictures and seeing those weird lines on the bottom of the ocean, apparently, that look like giant slug trails. Is that kind of what we're looking at there?
Right. And they do this and they do this strip, and they are saying that, okay, keep in mind, and that right here, this is, I need glasses on, 780,000 years ago, 900,000 years ago, a million. In other words, you're giving, this is the field here, this is the field there, but they're taking it at different 900,000 years ago, a million years ago, 780,000 years ago. And they've decided that because from measuring from here, this must be, if it goes this far, it must be this many years ago. And just like when we're anywhere else, it's like when you dig down, the further you go, the older it is. We don't have landslides or anything else that like affects that. Nobody ever in the past buried things. Nobody dug holes and put anything underground, and nothing landed on top. As you dig, things are just older. And that made me wonder about what size the Earth was before we kept on adding all of this stuff on top of it. But that's just another question when you get into the silliness of it with the globe.
Big shout out to Murray Cole. $20 super chat over on Rockfin says, enjoy your program every week. But thank you, Murray.
Thank you, Murray. I'm going to figure out how to, because I've got you guys, I'm showing the show now, so I suppose I can stop my screen.
All righty.
Thank you, Murray. We appreciate your support every week too. But yeah, before we wanted that, I wanted people to look at again some of what they put out on it. Also on the data they take a lot of good data. The interesting lunar distances and the missed distances of asteroids are another thing to giggle at. But you also have links where you can pull into all kinds of data sets. So if you want to know and see all the data they're taking up there, you have lots and lots of scientists taking information. And again, it's a crapshoot. You have to say, and again, my rule of thumb is if you have multiple scientific people actually taking independence, especially in different things that you can take the measurements all over, you probably have valid, because people do valids. And again, when you have to rely on a probe or something that they're feeding you the data, so it's trying to find the origin of it, is my rule of thumb on where I'm trying to determine the two. Because I actually, again, went to Boulder, tried to see what, and people are doing it. They're doing real things.
All right. So that's going to do it for Auroras, folks. My final conclusion is magnetic electrical phenomena taking place up in the higher altitudes of the atmosphere in the colder regions. When they become colder, have their winter. As far as where this, if it's extra electricity, which I don't think it is, because then we could also have it during the summertime. I'm thinking it has to do with something to do with the gases and how that cold atmosphere affects them in their, maybe the elevation of them. That's what I'm thinking. But
it's interesting how temperature has an effect on
everything.
Everything, yeah.
Everything.
So we're just talking about ferromagnetism, and you call it the Curie point, right?
Mm-hmm. Yeah.
Okay, I remembered. Yes. Okay. So the Curie point,
Marie Curie. Yeah.
Yeah, where metal loses its magnetism when it gets overheated.
Mm-hmm.
Curie point, also called the Curie temperature at which certain magnetic materials undergo a sharp change in their magnetic properties. In the case of rocks and minerals, remnant magnetism appears below the Curie point about 570 degrees Celsius.
Yeah.
For the common,
But-
yeah.
Yeah, that definitely leaves a question for the whole New Mexico aurora that someone mentioned earlier. And so, yeah, I don't quite get that either. So there's a lot of mystery in here that I just don't get yet. But yeah, it's worth exploring.
But the thing about it is even before it hits that dramatic Curie point where it drops off, before it does that, the hotter it is, the weaker magnets are, the colder it is, the stronger they are.
The colder it is, the stronger it is.
Yes. So magnetics work that the colder it is, the stronger the property of the magnet. The same with fluorescence, natural fluorescence. This is something fun. If any of y'all have kids and have those little, Kyle, you do.
Yeah.
You know, the little glow necklaces and things that they have that you bend and they light up and they glow.
Yeah.
Which, by the way, is made out of the same material as celestite, the strontium titanate that they mine celestite for, by the way. That is like the, again, the not gem grade, but the lower quality. They mine it, they crush it up, they make all of this stuff that glows. If you want it to light up and last longer, you put it in the freezer. You'll get a much brighter light. It will last longer. If you want to recharge it, put it in the freezer. If you want it to be very, very
You
weak,
can recharge it? I've never heard of that.
well, in other words, if it's not necessarily recharged, but when it's dim, you can brighten it up by making it cold. It'll actually go brighter again. Not a huge difference, but again, you can help it out a little bit if they're sad that it's there. You can make it glow a little bit for the kids by making it cold. And
when
again,
I think of a current, I think of motion, but when I think of something cold, I think of a lack of motion, which I think is a really interesting detail when it comes to magnetism and temperature.
They
like
say
less motion, all of a sudden there's so I'm trying to
actually in magnetism
stuff.
But in the way that they describe it in physics with the magnetism, they'll say that the colder it is, the more the particles don't vibrate and stay in a perfect alignment, so it's stronger. So this is how I don't know in actuality if this is true, but the way they explain it is by saying that when things are colder, they're less active, and being less active, they're holding a tighter collimation and a tighter focus because they're not so busy vibrating.
Interesting.
Now so it's not only magnetism that does that, but lights, fluorescent lighting. Again, the natural fluorescent of it, the colder it is, it's a cold light. The brighter it is, the warmer it is, the weaker it is. So you want those bracelets and other things they're bright, and you just want a tiniest of a glow. Heat them up; they'll be weaker. Is how it works in reality.
Yeah.
Temperature does affect everything, and again, with pressure mediation and the type of system we have, it sets the sun coming, warming things. Again, it's the dynamics of what you say, Zach, you don't ever want to stop.
Yeah. All right, folks. Well, that's going to wrap it up for the nerdy technical part of it. And we're going to talk a little bit about Flattoberfest. If you haven't heard, there is a Flat Earth Festival happening in Vegas, baby. Karen, would you like to speak on this a little bit?
Sure. We're going to be having a international flat earth conference in Las Vegas this year, 2023. It's the 5th Flattoberfest and the first year that we're international. So from the UK, we've got Dave Murphy and Mark Devlin, and we're also having Amanda Vollmer along with some of our stateside flat earthers like Jason Lindgren, Ben Balderson, Austin Whitsitt, Jaron Campanello will be there he's the first time him being at one of the Flattoberfests, and he hasn't been to an event since before the pandemic. So
yeah, it's been a while.
Yeah. And then so we're gonna have and of course Mark Sargent and David Weiss will be there. People always ask me about David Weiss, and I never put him on there because he doesn't present, but he'll be there.
Oh yeah. He's not going to miss it. I mean, come on.
Yeah, and Chief Crow and the Flat Earthworms will be playing live music, and there'll be a bunch of other fun stuff and giveaways, and it's going to be just a really great time. And It's going to be great to see you all there.
My wife and I got our tickets. Yeah.
Awesome.
If you're looking for transportation, like people driving from your area, there is a Flattoberfest Telegram group where people are getting together and, you know, working out rides and stuff like that. So we can get as many of us there as we can. Yeah, I cannot wait. This is going to be so awesome.
Yes. It's going to be amazing. 2 full days. We're going to have something going on the Friday before, most likely some sort of karaoke thing going on. So it'll be a full weekend.
Yeah.
Sounds like a
Hosted
family
by the
reunion to me.
man, Rick Hummer. That's how I
Yes,
always
hosted by
explain
Rick Hummer.
all these meetups. It's the family reunion you want to go to. You know, I mean, knock on wood, I have been to a lot of these. I think I've been to every Flattoberfest and Solar Return and a couple of the FEICs. And there has never been two flat earthers getting into an altercation. You know,
Mm-mm.
it's not like online when you have, arguments and this and that. People are so much more cordial, and it's the energy and the excitement, and everybody's just so happy to be there. It's not like you're going there with any animosity or towards anybody. And even if you are, that gets dissipated instantly
Oh,
just by
yeah.
your surrounding. You're
I
going to
don't
see
see
all these
how.
people, you're not going to care about some little, you know, nonsensical dispute you have with this one other person. It's not going to matter at that time. So yeah, it's different. If you've never been to one of these things, it's so amazing being around people where you could walk up to anybody and just start having one of what your family would call crazy conversations, right? And they're not
Right.
going to judge you or look at you crazy. They're probably going to have stuff to add to it or maybe
Yeah.
even educate you on the topic. Yeah, it's an
Oh, yeah.
awesome place to be.
Yeah, people
The
always
great
have,
minds get together.
yeah, people always they're up all night having great conversations, and everybody learns something, you know. It's it's great. It's unbeatable. You really have to be there to experience it. So,
Yeah, you really do.
It's
Is
like
Mike Tyson joining this year's event? I wish. That'd
I
be so
don't know. I
awesome.
haven't got any confirmation from celebrities showing up, except for Stefan from the Deftones.
Nice. That guy's
Stefan
so
will be
cool.
there. Yeah, he's totally down for the cause.
Solely
He is the
just
best.
down to earth. Just,
Hmm.
whenever I used to think of these, famous musicians, I always put them up on this different pedestal, like they were different than other people. But they're really not. They're just people, you
Hmm.
know? I mean, Rico, haven't seen him in a while. Hope he's doing all right. Rico's tinfoil sombrero.
Hmm.
But he was a drummer in pretty well-known band for like a decade, I think. And he's just, he's shy. He's not like big, boisterous, giant ego, this and that. These are just normal
Not
people,
that
a
those
lot of
don't
them.
exist.
No, they definitely do. You have your Mick Jaggers and your Eddie Vedders and well, Bono, I think, takes the cake for, yeah, biggest ego musician. Well, at least back in the day.
Yeah.
But yeah, they're not all like that. There's a lot of just bass cool. You can strike up a conversation with them. They probably prefer that you don't know who they are, you
Yeah.
know? Yeah, because then you could have an actual conversation with somebody, not somebody who's just going to hang on every word you say and adore everything that comes out of your mouth. So yeah, I can't wait to meet him. I haven't met him yet, but yeah, I can't wait. Shake his hand, say hi and thanks and all
Oh,
that good
yeah.
stuff. Yeah.
He's so cool.
Oh, I was trying to find his website last night because I wanted a flat Earth backpack and I couldn't find it. I could not Google and get to it. Where is his merchandise at, Karen? Because I didn't want to bother you either. I was embarrassed. I know you, and I know you've got links, but I did try hard just by Google saying stuff. I did Steph Deptom's webpage, merchandise, flat Earth merchandise.
Yeah, here I'll give you the link. It's oh wait, did it change again? Hold on.
Yeah, I cannot wait. We're getting close too. We're already at the end of August.
Unbelievable.
2 months and 4 days. Nice.
Here we go. mosaimusic.com/thestrong. Here, I'll send it
The
to you.
strong.
Thank you.
Awesome. Thank you, Nathan. Nathan says, Rico is doing great. Just talked to him yesterday. Awesome. Yeah, we haven't been doing Iron Realm, so I haven't been able to see it. I'm starting to really miss the Iron Scouts. Like, bad. Like, I was going to go live today just to see if any of them would jump in and say, hey. It's weird. They become family. A lot of you have become, family to me. The people that I see 3-4 times a week, it's and when you don't see them, it's it's weird. Love you guys.
Yeah,
Me
man.
too.
But I think that's going to do it. We will go through and let everybody say what they've been working on or are working on and all that kind of good stuff. Kyle, we'll start off with you. What do you got going on this week, sir?
I just finished putting together my my big battle round 3 of Ozian versus Flat Earth, and can't wait to get that published. Probably get that out in the morning.
Nice. Can't wait to see it. Karen, what do you got going on? I know Flattoberfest has probably taken up lots of the time and everything.
Yeah,
We'll be
it
having our
is.
scripture
But
this
I think
Saturday.
yes, we'll be back to doing
Okay.
anti-religious scripture study this Saturday. Last time Jack was busy working on something the day before and he couldn't translate. But we'll be back this weekend. And of course, Monday for Coffee Talk and Tuesday, Strange World with Mr. Mark Sargent. And that's it. Back here again on the Thursday, all over again.
Richard Strock in chat asked, can we get a Gyros part 2? That is a good possibility, and maybe we can get John Savage and maybe even Rob Durham in on that chat.
That would be great. That would be really good. Also,
That would
Chad,
be
if
awesome.
you have show ideas you'd like to see,
Please, yes, share
let
them
us
with
know
us.
for
Drop
here
them in the
or
comments below, or
here
even over
or
on GLOBEBUSTERS main show, because I see all those comments too. So if you guys have any ideas for a show that you'd like us to cover here on Tech, please let us know. We're looking for new ideas.
also if you'd like to have any ideas you'd like to have on the primetime show on Sunday, let us know too, because am in contact with them, and they're always looking for good ideas and things that people are interested in and want to focus in on. So
Absolutely. So Cammie, what do you got coming up this week?
oh, I don't even know. It has been a week. We have got, of course, GLOBEBUSTERS on Sunday. I've been sneaking in and watching all the great stuff the GLOBEBUSTERS have been doing. Jaron did a stream today with, what was the name of the channel he did it with? Because that was a good host, actually.
I'm not sure.
Boy, I could look really quick. It's not too far away because I started saying it and I watched. I can't. Enter the Asylum. And it was Enter the Asylum on the original Discord Asylum. So he did that. Witsit, Jaron, Witsit, Dave Weiss, they have all been on such a good roll lately with all of the shows they're doing and hitting all of the outside channels. I know Dave Weiss did one with Andrew Gold, which was a channel I'm subscribed to anyway, so it was fun to see the Flat Earth come up on it. So again, everybody is doing so much good stuff, and it's just trying to keep up and push forward right now. So I think that's about it. Yep.
Well, since Iron Realm has been down, I haven't really been doing much. I was going to go live on my channel just to hang out with the scouts and stuff, but this is what I've been doing with my time. Here is the new Flat Earth map for Fortnite. It's getting really close. We're starting to put stuff in now. So we got Flat Earth farms. We're not going to be able to have like 10 buildings on each continent, unfortunately. We're going to be limited to like 2, maybe 3. So we're going to have, there's Dave's boat. That's his yacht. the Flat Earth Yacht Club. It's really a
Awesome.
pirate ship, but yeah. And then we have Flat Earth Farms here. We're going to put some farm stuff in the back there. And then Flat Earth Pizza is going to be out here, somewhere out here.
That's cool. Did you know they sold Flat Earth Pizza though? They don't have it anymore.
Well, he opened a new one in Southern California.
No, they haven't. They want to.
Oh, okay.
So yeah, I guess you put it Southern
Okay.
California. They're trying to open one. Well, at least that's what I got when I talked to them at the premiere, that they were working on opening one.
Okay, yeah, I'd heard that he's no longer in Nevada and they had
Mhm.
moved to Southern California, but I hadn't heard that. Yeah, okay, that makes sense. But I'm still going to put it in there. I want to put
Yeah,
it in
that's
there.
cool.
So Flat Earth Pizza will go there. Iru was telling me about a supermarket down here in South America, like just a market that had a big Flat Earth banner. So I'm going to do some kind of supermarket type thing or grocery store. It'll be the Flat Earth grocery store. But if you guys know anybody, I have put word out to Mark Sargent to ask, because he really has the ear of the internet hive mind.
Mhm.
And I need more Flat Earth stuff, businesses or like something. I mean, I could even do like billboards that have, if you want a website or something like that, and I can
Survey.
just put those.
I've heard of flat Earth surveyors out there before.
You can put a Flat
Yeah,
Earth festivals there.
yeah, definitely. I'll have flatearthfestivals.com on one of the billboards for sure. But yeah, I plan on having a few different billboards. Flatearthdave.com is going to be on the side of his boat right here, real big.
That's hilarious.
Yeah.
But is there room in the Carolinas to put a Flat Earth Festival sign in Carolinas, or?
Oh yeah, we could put one
Yeah.
like right here. Flat Earth
Yeah.
Festivals, or like
Yeah.
this way. Yeah. Flatearthfestivals.com.
I like that. We
Just
thought
for
about
things
Carolina,
for
but we didn't want to invite everybody to Carolina. It's my special place. I'm not going to share.
Oh, well, you could put a NASA building in there that we could go destroy.
That would maybe be something, a bomb area. That's not a bad idea. Search and
big
destroy.
shout out to Nemo 289V289. If you see him in chat, tell him he's doing a great job. He's been helping me out with all this stuff. It's so much easier when you have someone to bounce ideas off of and just help you out with it a little bit. Makes it go so much smoother. But yeah, it's coming along. So I don't think it's not going to take a month. I did all this in like a week, where the last time this all took me a month. So maybe a week or two tops, and I think we'll have it ready to go and people can start playing it.
Sweet.
Yeah, I'm excited. But yeah, that's going to do. That's what I've been up to lately. Not really. I'm not in research mode right now. I'm not in testing mode. I don't know what I am. I'm kind of
It's okay to take a break.
blah. Yeah,
Yeah.
It's okay to rest that stuff.
Yeah. Yeah, you can't be on 24/7.
Unless you're David.
Yeah, I was just going to say, unless you have David Weiss blood running through your veins. I don't know how the guy does it. Or you, Karen, for that matter. But thank you all so much. I hope you enjoyed the show. Again, if you have any ideas for new show topics that you'd like to see, please drop them in the comment section below. And yeah, we'll start maybe hitting on some of those. But the Auroras, what they actually are, not 100%. Need real data. And I think before my lifetime is up, it's going to get to that point where we start getting real data for all this money that we put into this thing, where this place we live, this taxes and all that good stuff. We're going to start getting our money's worth one of these days, and it's going to answer a lot of questions.
Mm-hmm.
Powers that be are shaking.
Oh yeah, they're terrified. They're in damage control mode big time. That's why we see all this alien agenda stuff coming out. Oh my goodness. Well, we're not even going to get into that. It's time to get going. But, oh my goodness, we could do a 5-hour show on just
I was going to say, that'll
all
be
the
4
alien
more
stuff.
hours.
Yeah, coming out. Oh my goodness, it's everywhere. But that'll do it, folks. Love y'all. Thank y'all for joining us. Remember, be good to each other. Don't lie to each other. Open your mind because there's truth inside. Peace out, everybody.
Peace.
Peace, y'all.
Peace.